Now a little bit of guidance. You've been trying to draw this on your own. I want you to draw 3 different perspectives. I want you to draw a top view, as if you were in the sky looking down, straight down. I would like you to draw side views, if you were looking at the tower in David and the tower in Brenda. And then you can try this. Try drawing a 3-dimensional view of what's going on. And for the side views, the reason I have side views is because you're going to make one for David and one for Brenda. All right, so now you try this on your own. If you were doing a top view, you would have north here, south here, west here, and east here, with the tower, which I'm going to draw in red, right there. David is due north, so I'm going to put a dot here for David. That's where David is, due north. He is some distance. I'm going to draw that line in blue. We don't know how far away David is from the tower, but he's some distance away from the tower. I'm drawing that in blue. And then Brenda is on a bearing of 175 degrees. So bearings measure from north 175 degrees, excuse me, is almost 180 degrees. And I'm going to draw a line in green for Brenda. We don't know how far away Brenda is. There's Brenda at 175 degrees. That is the top view of what's happening. There's a tower. David's due north. Brenda is at 175 degrees. Side views. Well, when you get to the side view, now you can see the tower. And I'm going to draw that tower in red because I made a red dot. And I know that that tower is 35 meters. And I'm going to start with David's drawing. He is some distance away. Here is David from the tower. And we know the angle of elevation to the top of the tower is 70 degrees. We can also draw a side view for Brenda. Same tower, same height, 35 meters. Brenda is a certain distance away, I don't know. But her angle of elevation is 50 degrees. And in both of the side views, since the tower is going straight up, we know that these are 90-degree triangles. So we did a top view and a side view. And I color-coded things so that this blue line on the side view for David matches up with this blue line here. And this green line, which is the side view for Brenda, matches up with that green line there. Now what we have to take is we have to imagine that top view with these side views built in. Can you see that this triangle would have to get lifted up and placed so that the red tower is pointing straight out on the top view? And this Brenda's one would get lifted up and placed on there. The green line matches up and the red tower is coming straight out. So now, how do we draw 3D pictures of this? And we have to imagine that these triangles are glued on here. We're going to pick this up, rotate it a little bit, and put it down. And the way that that's usually done is by starting off by imagining that this north, south, east, and west was on a piece of paper that was on a table drawn in 3D. So I still have my west and my east on there, but then at an angle, I put north and south. Can you see that that's still 90 degrees, but it's like a three-dimensional view where this is like put down on a table? And then have your tower, which is 35 meters, come straight out of the top of that. Now, we know that David is somewhere on due north. And so I take this triangle that I drew and I label this as that blue side there. This would be 70 degrees right in there. Then Brenda is right there. This is her line of sight to the top of the tower, and we know that this angle is 50 degrees. We also know that this angle between them was 175 degrees. What we want to find is the length between you can see it on the top view, you can see it on the three-dimensional view. We want to find the distance in between them. So, we have to see where all of the triangles are and what we can figure out. I hope you can see from the side views that those are right angle triangles. So we can use SOHCAHTOA on those right angle triangles, and we have 3 pieces of information, so we can solve that completely. We want to find the purple line, and that purple line we can see in the top view. The problem with the purple line in the top view is the only triangle that you see, you only have 1 piece of information. You have the angle is 175 degrees. So this is problematic because you need 3 pieces of information to solve any triangle. And we want to find the length of that purple side. So when I look at the top view, I'd be like, well, I need 2 more pieces of information on this top view, and then I could solve for the purple side. Is there any way that I could find those other pieces of information? And then I look at my side views, and I'm like, ooh, I could find the blue length, and I could find the green length. I'm going to pick variables for these. I'm just going to go alphabetically. I'm going to call this one A and this one B. And can you see that you could use SOHCAHTOA to find A and B? So we'll do that right now. We'll start with A. I'll do it in blue. I'll say I'm going to find A. How do I do that? Well, if I use SOHCAHTOA here, A is the adjacent side. I know the opposite side, so that tells me I should use tangent. Tangent of 70 degrees will equal the opposite side, which is 35, over the adjacent side A. Multiply both sides by A and divide both sides by tan of 70 degrees, and we get A by itself. Then I can do 3.5 divided by 10 of 70. And I get A is 1.27. No, not 3.35 divided by 10 of 70. 12.739. So I can label that here. And I can also label that there, because I figured out that value. Something that, I'm going to show you some cool things that you have built into your calculator. So I'm going to do this on my calculator as well. 35, maybe. Oh, let's see what happened. So on my calculator, just because as you get used to using this calculator, it's going to help you a lot. And I was just about to type mine in, and then I realized my calculator says it's in radians, so I'm going to have to hit my mode button and make sure that I'm in degrees. Push enter, and I get the 12.739. And one thing that's really nice about your calculator, I know I'm going to have to use this later, so I'm going to, above my on button, I hit store, and I'm going to store it as alpha, and then push A, because I called it A, so that it's easy to remember for me that later on, when I want A again, I've already got it stored as A. Now we're going to do the same thing and find B. So we're going to go back here, I'm going to switch to green, I'm going to find B, same thing, I can use tangent. Tangent of 50 is opposite side, which is 35, over B. So B is going to be 35 over tan 50. I'll go back to my calculator. 35 divided by tan of 50. 29.368. And I'm also going to hit the store button here, and this time use the letter B. So now I've stored A as 12.739 and B as 29.368. I can go back here and label everything I know now. I know that this is 29.368. I can label that also on here. I could label them on the blue and the green on that 3D one as well. But now in my top view, I'm like, now I have a triangle that's not 90 degrees, that has 3 pieces of information. And it happens to be side angle side. So I look at that triangle, it's not a 90-degree triangle. I cannot use SOHCAHTOA to solve for x. So then I look at the sine law. Do I know the angle and an opposite side? That's a requirement for the sine law. And I know the angle, but the opposite side is the one I want to find, not one that I know. You need to know an angle and an opposite side and one other piece of information to use the sine law. So then this becomes, oh, I have to use the cosine law. So now to find x, we have to use our cosine law. And again, I'll write the formula from your formula sheet. But again, on the formula sheet, we're using x, and we're using A and B. We don't have C on our formula sheet. However, the most important thing is that whatever we're solving for, whatever angle, always goes with that opposite side. So for us, switch back here to purple, we're solving for x. So the angle that went with x was that 175 degrees. A happened to be 12.739 squared. Oh, I'm going to run so badly out of here. Okay, I'm going to start writing smaller here. 29.368 squared minus 2. Then the blue number. Are you okay if I, it's really tiny. I just did dots, but can you pretend those dots are actually the numbers so tiny that you can't see them, that they look like dots? I think we can imagine that. Now, here's the nice thing. When I go back to my calculator, because I've stored them, I can just go a squared plus the b squared minus 2 times a times b cos of 175 without having to retype them in, without having to go up and, like, you could select them as well.
Do you have formula sheets?
Yes, and I gave one to everyone except for you, which was on purpose. There we go. Now when we push enter here, it remembers those numbers and it tells us that x squared is equal to, oh, my memory is not good, 1770? Oh, not bad, 0.189. And then I could solve for x by just square rooting that answer. Second square root, I like to use the answer button sometimes, right next to the equals if you push second, and the negative sign if you get the answer. And we get 42.074. So reread the question to make sure we've rounded correctly. It says to the nearest meter. Okay, everything else was in meters. And what is the distance? So I'll round this to the nearest meter. Make sure I include my units. And we get 42 meters in the end. So circle questions 9 and 12. And I think this is a good example of where if you just tried to draw one picture, maybe you tried to draw the 3D picture, it gets really messy in there. And it might be really difficult to put all your numbers in and see things from that perspective. So having different perspectives like this top view and these side views really helps you break things down, make it a little bit simpler, and then say, what can I solve for? What helps me? And then be able to work from there.